Section 8.3, graphing f of x equals ax squared plus bx plus c. So we're finally up to the full standard form of a quadratic function here, ax squared plus bx plus c. We started just with the ax squared, then we introduced the constant, and now we're going to make it a little bit more complicated by including the bx. When we're given that equation, we can actually figure out some important information about the graph. One thing that all parabolas that we'll look at will have is a y-intercept. Of course, the y-intercept is the point on the curve that's going to hit the y-axis, the vertical axis on the coordinate grid. And we find that just by actually using the point 0, c, where c is the constant at the end. That makes sense. If we plugged in 0 for x, the first two terms would disappear. And so if you look at the parabola I have graphed here on the right, it has the equation y equals 2x squared minus 12x plus 8. That 8 is the value of c. And so the y-intercept of this is the point 0, 8, which I've shown right here on the y-axis where the curve hits the y-axis at that location. Now, the other important point that I've highlighted is 3, negative 10, which is the vertex. Now, the key to finding the vertex is to first find the axis of symmetry. What that is, for these parabolas, is a vertical line that goes right through the middle. It's really like kind of a line that serves almost like a mirror, and we get the same image on either side. And the equation to find that is to use x equals negative b over 2a. So for this problem, since I'm given my original equation, 2x squared minus 12x plus 8, I'm going to use the formula x equals negative, now b is negative 12, all over, or just over 2a is 2. Now I just simplify that. Negative 12 is 12, 2 times 2 is 4, and I'm looking at 3. So the axis of symmetry is the vertical line x equals 3, which I'm going to draw in now. So you can see this vertical line here has the equation x equals 3, and the vertex is always going to sit right on that axis of symmetry, because that's where the parabola turns around and it starts to look like it's a mirror image. So in order to find the coordinates of the vertex, all I would need to do is plug that value of 3 into my equation. And so I would do y equals 2 times 3 squared minus 12 times 3 plus 8. Using the order of operations, I'm going to get 3 squared is 9. Minus 12 times 3 plus 8. Then I'll just finish this up here. Do the multiplication. That's 18 minus 36 plus 8. And then do addition subtraction from left to right. 18 minus 36 is negative 18. Negative 18 plus 8 is, in fact, negative 10, which matches up to this point right here. So that's how I would find the vertex, which is the other important piece to find. So anytime you're given the equation, y equals ax squared plus bx plus c, the c tells you your y-intercept, and negative b over 2a tells you your axis of symmetry, which then you plug in to find the y-coordinate of the vertex. And that's all you have to do. Okay, so sometimes we don't necessarily need a really good graph. We're just okay with a decent sketch. And so one way we can do that is we can look at the equation and figure out a few key points. So first of all, we know f of x is 2x squared plus 8x minus 1. That's our problem here. First, we want to determine the axis of symmetry. So the axis of symmetry comes from the equation x equals negative b over 2a. In this case, my b is 8. My a is 2. So I'm looking at negative 8 over 4, x equals negative 2. vertical line going through the x values of -2 is the axis of symmetry. The coordinates of the vertex. I have to take that -2 and plug it into my equation. I'm basically looking for f of -2. So that's 2 times -2 squared plus 8 times -2 minus 1. Now, order of operations, remember exponent first, but that's -2 squared, which is a positive 4, and 2 times 4 is 8, plus 8 times -2 is -16, minus 1. That's going to give us -8 minus 1, which is -9. So the coordinates of the vertex are going to be -2, -9. So that's an important thing to keep in mind. Next, we're going to actually plot the vertex and y-intercept. So my vertex will be the first point that I plot, which is -2, -9. And the y-intercept, remember, is the point 0, c. And in this case, that's going to be -1. So I'm going to have 2 points, and that's going to be where I can start. I can analyze A to determine if the parabola should open up or down and wide or narrow. Now, in this particular case, because my A is 2, which is positive, I know it's going to open up. And because 2 has an absolute value greater than 1, I know it's going to be relatively narrow. So, now I'm going to go ahead and graph this on this coordinate grid. I'm going to bring this front and center. And I'm going to plot the points that I know. First of all, I had -2, -9 is my vertex. And I know that 0, -1 is my y-intercept. And I could actually think about my axis of symmetry as well. The fact that that's x equals -2, because I can treat that as a mirror, and I can find that there's going to be a point directly opposite of 0, -1 over here at -4, -1. I can actually match that up nicely there. And then I just connect the points that I have, and I try to make it a relatively smooth curve. It's not always great. Just do the best that you can. Again, we're just looking at a sketch here. And that looks like it does open up, which we expected, and it is relatively narrow compared to the regular x squared. So we're in good shape. So that last example was a sketch. Sometimes we want a really good graph, and a graph would require more points that we find with certainty. So we're going to really graph it really well by first determining the vertex. And I know to find the vertex is 2 steps. I first find the axis of symmetry, and then I plug that value of x in to find the y value for the vertex. The equation is y equals 3x squared minus 6x plus 5. So to find the axis of symmetry, I do -b over 2a. Again, that's what x equals, which in this case is -6 over 2 times 3. Well, -6 is 6, and 2 times 3 is 6, so I'm looking at x equals 1. Now to figure out the actual coordinates of the vertex, I'm going to plug in that value of 1 into the equation. So I'm going to have y equals 3 times 1 squared minus 6 times 1 plus 5. And you can go ahead and do that. And when you do that, you're going to get 3 minus 6 plus 1. -3 plus 5 is 2. So my vertex, I'll call that point V, has the coordinates 1, 2. So now what we're going to do is we're going to make a table to figure out all 5 points that I need. I'm going to make a T-chart here, X, Y. And in the middle, I'm going to put my vertex. I've already figured out that it has the y value of 2 associated with the x value of 1. Now, in the past, I've used -2, -1, 0, 1, and 2 every time. But here I want to have the vertex be the center. So I want to go 2 values below that, which would be maybe 0 and -1. And 2 values above it, probably 2 and 3. So go ahead and fill in the table with those values, plug them into your original equation, then come back and check if you have the right points. Alright, how'd you do? So what you find here is that it should be kind of mirror images as you move away from the vertex. This is what the axis of symmetry does. Alright, so now we're just going to go ahead and plot these points, and we will put them on the coordinate grid that I have here and make our parabola. So, starting off, we had the vertex, which is the point 1, 2. Then we had the point 2, 5 and the point 0, 5. Now we did have the point 3, 14 and negative 1, 14. We can't quite fit those on there, so we're a little out of luck there. But no worries, we'll just connect what we can and draw a relatively smooth curve. That's pretty decent. And there you go. There's another parabola graphed. Alright, so just want to take a look at one particular example of a word problem that this could be connected to. These are the type of people I'd like to hang out with. A group of friends trying to launch a water balloon into the air as high as possible. And their first balloon had a path that's modeled by this equation, negative 16t squared plus 80t plus 5. And the second trial is shown in the graph right here. So this is the equation for the first one. This is the graph of the second one. So the question is, which balloon went higher? So the way to figure that out is to think about the maximum height of the balloon is going to be the vertex of the balloon. Because this is a negative 16t squared, I know my parabola, like the one in this graph, will up and down. Therefore, its vertex will be at the very top. It'll be the peak. It'll be the maximum height. So you can see what the maximum height is here. We'll actually discuss what that is in a few minutes. But first, let's figure out what the maximum height is of this equation, which is separate from this graph. To figure out the vertex, I first have to find the axis of symmetry, which comes from the equation x equals negative b over 2a. In this case, that's negative 80 over 2 times negative 16. Now that's going to be negative 80 over negative 32, and the negatives will cancel. And so I've got 80 over 32. Now, if I go to reduce that, it's actually divisible by 16, both of them. So I've got 5 over 2, 5 halves. And now I'm going to go ahead and plug that into my equation, get y equals negative 16 times 5 halves squared plus 80 times 5 halves plus 5. And actually what that 5 halves means, just as a heads up for those of you who will be taking physics a couple of years, 5 halves is actually the 2.5 is the number of seconds it takes for the balloon to reach its maximum height. So that's just a little thing there. And so go ahead, use a calculator, take your time, figure out what that is, then come back and just check your work. Alright, did you get the right answer? So what we see here is the first balloon got launched to a total height of 105 feet. Pretty impressive. However, when we look at the second balloon, the vertex right here has a y value of above 125. Can't tell exactly what it is, but our scale there is by 25. So our second balloon actually ended up going higher. Must have adjusted the shot a little bit to make it better. So just a little thing that you can do using this information. You can find the vertex, and that can figure out perhaps the maximum height of what we call a projectile. All right, hope this makes sense.